So now I want to show you how we can find arc length if we have a vector valued function. So remember our vector valued functions, they come as this r of t, where we have the x and y components defined independently, and of course we can add a z component if we're in R3. So I have a little picture over here to kind of get our bearings. So if we're thinking of the length of the path from t equals a to t equals b, but our function is defined with these vectors. So remember, right, so here's our path C being traced out by the tips of the vectors as the vector, right, moves from a time t equals a to time t equals b. And so this little chunk right here, right, is that little chunk of the change in r, right, over the change in t. So as time changes from, right, say a j to a j plus 1, your tip is going to trace out this little chunk of the path. And just to kind of just like say, oh, okay, that makes sense, right? So back when we did it, when we weren't vector defined, right, we would look at it was a parametric equation, right, a parametric function, we would do the change in x squared plus the change in y squared, right, square them, add them, root them, and integrate. So we integrate because we want to add up all of those little bitty chunks of the arc length that we're looking at. Okay. So one little chunk would be, right, that delta x squared, right, delta y squared, square root, and then we add all of those up. Well, that's just what this is here. So I have my delta x, or x prime, because it's changing with respect to time, squared, plus y prime squared, right, change in y with respect to time squared, square root them, right, because it's Pythagorean theorem, and we, right, just want the one part, not it squared, integrating with respect to t, and then we'll add all of those up from a to b, which is the integral. Okay, if you go to R3, it's the same thing, except we'll add on that z prime squared, and our r will have a z of t component. All right, so hopefully that makes enough sense. I know it's hand wavy, but wave, wave, wave. Here's our formula. If you're a note card making person, I would have these three along with the definition of what you're finding and maybe the picture on a note card. All right, so let's go ahead and practice one. So find the arc length. So here my r of t, I have t, comma 4t to the 3 halves, comma 2t to the 3 halves, and we'll find the length of that path as t changes from 0 to 5. Now, just like arc lengths back when you first started talking about them in Calc 2, arc lengths are kind of tricky to find sometimes because the integral has to be just so, or it's really hard to find the antiderivative. So the first thing we're going to do is we're going to set up our arc length formula here. So it's from a to b. So here's a, here's b. So 0 to 5. Square root. Okay, maybe I'll have a little workspace up here. So I need x prime. So that's the derivative of t with respect to t is 1. Squared. I need y prime. So let's figure out what y prime is over here. So y is 4t to the 3 halves. So y prime, so derivative with respect to t, I'll have 4 times 3 halves. T, take 1 away, so 1 half. Okay, so that's going to be 2y prime is 6t to the 1 half, and now I need to square it. Okay, so that'll be plus 36, so squaring the t to the 1 half, that'll just be a t. Okay, that was pretty nice. And now we'll do the next one, and that's, so z equals 2t to the 3 halves, so z prime equals 3t to the 1 half. So square it, that'll be plus 9t dt. All right, so let's tidy that up. So 0 to 5, square root, what do I have? 1 plus 45t dt. Okay, and this is S. Oh, I better go back to my cursive S because there I've got S's and 5's together, wouldn't you know? Okay, I'm going to zoom in just a little bit. That's just a quick little u sub, and we'll do it in our heads. All right, so if u is underneath the radical, du would be a 45 dt, so I'll need a 45 here to get my du. Hold on, let me focus. Thank you. 1 over 45 to balance. So now I have 1 over 45 integrating u to the 1/2 du. I'm not going to put my limits on because I'm going to change those up in just a second. I'll go back to my t's. So 1/45, thank you, 1/45. U to the 3/2 divided by 3/2. Back to t's. So I have 2 over, let's see, 45 times 3. That looks like 135. U, which is, right, 1 plus 45t, to the 3/2 from 0 to 5. Yikes. Okay, I'm going to pause, grab my calculator, find those values. So what I got, so when I plugged the 5 in, I got 224. Plugging in 0, that's just a 1. 224 to the 3/2 didn't actually turn out to be anything nice, so I will just leave my answer like that. Okay, let's do one more. Move my camera this time, almost running out of room. Okay, so here's my r of t. So we'll set up our integral to find the arc length s. S is a really common letter for arc length. So 1 to 8, square root. So let's see if we can do this next one in our heads without writing down our derivatives and our squaring. So the derivative of x is 2. Square it would be 4. Plus. So this next one I have 2t squared. So the derivative of 2t squared is 2t. Square it. So that'll be 4t squared. Okay. Plus the derivative of natural log t is 1 over t squared. 1 over t squared dt. Okay, so now I'm only picking ones where we can actually find the antiderivative, which means I'm supposed to be able to find this antiderivative. So we're going to go ahead and add these guys together, getting a common denominator, hoping for the best. So we're going 1 to 8. So get a common denominator under there. So t squared's on the bottom. So I'm going to get, so this first, I'm going to do some algebra here on the slide. So I'm going to write this term first, this 4t squared. So t squared top and bottom, that'll make it 4t to the 4th. And then I'll grab this 4, so it's a t squared top and bottom, so that'll be a plus 4t squared. Okay, and then I have this 1 that already had the common denominator, so I'll just do plus 1. Everything's under the radical, including that denominator t squared. dt. 1 to 8. So when you're doing your homework, right, which I'm hoping that you're doing, you'll know to keep working, right, doing your algebra magic to see if you can simplify it. As long as it, in front of the question, it doesn't have like CAS, computer algebra system, or T for technology, like they don't want you to do it in on your calculator or something. Right, that means that you should be able to find the antiderivative if you look hard enough using all of your strategies. Okay, so the numerator actually factors. That's a perfect square trinomial, which is nice. So that'll be 2t squared plus 1, quantity squared. Now I have everybody under my radical. Thank you, dt. Is a perfect square, something squared divided by something squared. That means I can square root it, so I will. Back over here. 1 to 8. So now I have 2t squared plus 1 over t. Radical's gone because I did that operation. Split it apart into 2 fractions. So I have 2t plus 1 over t dt. Same limits, 1 to 8. Here we go. Done writing my integral symbol. Here's the integral. So I'm going to get t squared over 2. We'll cancel that too. T squared. And then if I integrate 1 over t dt, that's going to be natural log t between 1 and 8. Oh my gosh, finally. Okay, so we're going to get 64 plus natural log of 8 minus 1 plus natural log of 1, and natural log of 1 is 0. So 64 minus 1 is 63 plus the natural log of 8.